Thank you very much. So, hello everyone in the room and online. My name is Phil. Two secrets you need to know before I start this. Number one, I am not used to presenting sitting down. So if I wave my arms a lot, it's my legs kind of acting out, I suppose. The second one, I am a total and utter imposter, okay? Now, I have absolutely no training in engineering. I work in an engineering department. I have absolutely no training in computer science, and I am here at a computer science conference. This is going to be fun. Okay, so I thought I'd bring something a little bit different. I joined Margaret's team 4 years ago and a month. And Margaret is obviously very established. You will know her. She's done a lot of activities using lots of different coding languages. And I came into this thinking, I can mix chemicals and make them change color. So I had to pick up the process. What do we do with all of this? So I have seen a lot of these block-based coding languages from an outsider's perspective. I have maybe a different view on some of these things to some people here. Hopefully I don't say anything controversial, but we'll give it a go. So we work at the University of Warwick, right in the middle of England, as far away from the sea as it's possible to get on that island. And in the picture, you can see me, Margaret, and Marie, and we have another team member, Caroline, who wasn't there on the day that we had the photos taken, so unlucky. But we do a lot of different activities. We go out and talk to people, we talk to the public, we talk to young kids. The strangest one I've ever done is in the lounge of a retired person. She dragged every chair from her garden, every bit of patio furniture into the lounge, and I presented on her TV. We've been there, we've spoken to them. We do workshops, as some of you saw this morning with Margaret, working with equipment that we can bring out, so showing people how industrial equipment can be controlled with code. We've built some props and some demonstrators and things like that have ended up on TV at various points, crowning moment of my career, I think. We also bring students onto the university campus and show them the kinds of kit and the experiences that we have got. Many of the other things on there are things like activities, and this was one that was built by some of the technology volunteers who I believe came with Margaret 10 years ago. Is that right, Margaret? Yes, so there you go. And what they've got there are some blobs of Play-Doh that make the buttons for an arcade game for Tetris. So we take a lot of code out to places. In the UK, there's a good reason for me to do this, for universities to charge their fees. They have to support young people in communities. The UK economy is heavily dependent on engineering and on subjects that involve engineering. And right up to the top of government, there is this idea that we need to have more engineers and more skilled engineers. So they make jobs like mine, where I have to go out and encourage people to be engineers. Hey, come and give it a go. Pick up a spanner. But the problem is that what the traditional view of engineering was, kids in schools now think, if I say to them, what is an engineer? They will tell me someone who works changing car tires. They'll tell me someone who uses a screwdriver all day. They will not think of somebody who is programming self-driving cars. They will not tell me that it's someone who works in JavaScript or is working on the back end of some software somewhere. All they will think about are spanners, screws, screwdrivers. So we have these barriers when we try and say to people, come and study engineering, and then, by the way, here's Python. Off you go. I've got my bolts with me. What do I do with these? There's also a challenge of representation, that we have a predominantly male workforce and predominantly from certain backgrounds in the UK, and we need to make sure that we are making activities that are easy for anybody to get into so that they can have that experience and break down these barriers of representation. So that's a big personal motivation for me doing this. So it's not an easy thing to go out and tell people to be engineers. So when we then say, right, here's some kit, write a program for it, it can be quite challenging to just show people a load of code and say, here you go, get on board with that. Quite often a challenge that we give to students, or historically the way that programming certainly at least was taught to me, was a very A to B route. Here's your starting point, a blank screen, here's your end point, and there is no deviation from that route. You have to achieve these things. I've got copy from the book in there. That's how I learned programming when I was maybe 8 or 9 years old, my dad was using Turbo Basic, and I picked up the book and started copying from the book, and that was my experience of programming. I haven't brought the book with me today because Welling said that it might down the plane. It's a huge book, and unfortunately, a lot of the time with that, you spend all your time typing and copying from the book, and then the code doesn't work, and you think, what? Which semicolon have I missed? That's an experience. I'm seeing some nods. Everyone has missed a semicolon or a curly bracket at some point in their life and wasted a year trying to find it. So if we get stuck in all of that syntax, and especially students who maybe have low confidence to start with, we can lose them at that point. So what are the solutions? And I do not need to preach this in this room because everybody is already converted to this. Obviously, blocks are brilliant. We're getting away from some of that syntax. We're having more time to explore and create and play around with things. Controversially, this is not micro blocks, which I probably should have done. I've used make code, so I'm going to hide behind the laptop for a second. But we also get lots of boxes of kits and microbits, so there was a perfect introduction to that just now. I could not be more topical. And we give students free rein over what they should do with it. Now, something like a traffic light, fair enough, very prescriptive. Make it light up. What order should it go in? Well, if you don't want cars to crash, probably the same order as the ones out on the road. But then what happens is students surprise us. We gave them a starting point of make these traffic lights work, and they got red, red and amber, green, back to red. Cool. I was thinking that maybe what they'd then try and do is make them talk to each other, and that's where my brain went. But the students went somewhere else, and they found speakers, added a speaker in, and made it beep. Because of course, that's what it should do for accessibility, so that people who can't see that green light know that there is a green light and it beeps. So they had that creative freedom to go and take it somewhere else and do something that they cared about with that light. We like that because it gives students this feeling that they are in control of what they're doing. They're not just sat in a room copying from a book. They are now taking a project and doing something that they like with it. Don't get me wrong, that can end tragically when students spend 3 hours, 30 of them, all making the same beeps on a microbit. Who added a speaker to that thing? Seriously, that was a bad call for teachers. But what we do is we get a load of challenges that have a vague suggestion of a direction and a starting point and send people off, and we rely on this block-based code. So, my title was kind of challenge, context, creativity. The first step of that is the challenge. And when we do these big projects, maybe we have a whole week to work with people, we will come up with a set of challenge cards. They will start with something vaguely, maybe a little bit of a pun in the title or something a little bit open that they can work with. So we've got a piece from Kitronic that's the access bit. It's just a servo motor on a little stand controlled by a microbit. Or the one in the middle, that makes sense, so advertising. So give them some context. So that's what the challenge cards look like, printed front and back, and we give them an opportunity to go and do something with an LED screen. So we give them a hint starting point on that. I'm revealing which football team I support as I go, trying to humanize it, make it relatable, all of those kinds of things. But then there's lots of other avenues you can go down. If you've just got kit and some code, we have the opportunity for things like an ultrasound sensor to stop a vehicle if it gets too close. We had the fun challenge of transmit a secure message. We trialed this at a workshop last summer. I had an idea of where this was going to go, and the infinite creativity and ability to cause trouble of teenagers surprised me. When I thought I was the person doing all of the hacking in the room by sniffing out any errant radio messages and kind of pulling them and putting them up on the screen, until the students realized that they could just scroll through every radio channel, broadcast a random message, and it destroyed everyone's projects in the room. So they had great fun working out that they could cause problems by breaking this encryption. But again, in that room, in the moment, we suddenly had a new challenge that we had to solve, which is a lot like real life. So having that open end of what students are doing with this code allowed us to touch on new subjects and do new things with it. We give them a starting point, because often this is something new to people. Was that interference me? I can lean back a little bit. No? Okay. We can give them a starting point and try and give them a little bit of a hint of what to do, but we try not to give them too much. So I think the puzzle structure that we saw earlier from Jens, that's perfect for this kind of setup, and we'll definitely be using that, because this whole structure of how should the code look, we can give people that and allow them a safe place to go and try some stuff, see what happens. We find it really, really valuable to provide context. Why are we doing this? Why do we want students to spend their time in code, dragging blocks around, doing this, that, and the other? So I quite often make a little town map. So a grid structure, we're in Barcelona, so a grid structure for a city is very topical and suitable. And then when students complete a challenge, they get to go and sticky, like a blue tack, Velcro, whatever you like, stick their completed challenge card on the town map. So by the end of the session, we have a complete town, because everybody picks up something different. So you can show the students that within this room, we have everyone we need to build a future society. Job done. We've built that in them. We've built that confidence. We work at a university that has a lot of applied research and getting things ready for the street, so we can bring those kinds of technology. So I'm not just saying, hey, make a robot vehicle. I'm saying, here's our friend Charlie from the marketing team with a self-driving taxi. You need to build the code for it. She's about to get in it. Keep her safe. Charlie's nice. We don't want to kill Charlie in some kind of self-driving car accident. Funnily enough, the big problem we have with self-driving cars at Warwick is geese. But there you go. You can't solve that with software. And then we also do an introductory challenge, which is to show people a picture of something local to them and get them to think about where code, where programs, where tech is important in that environment. So that's a picture of the airport I flew from yesterday, and the students were thinking about why we might need technology in all of that. And then in the perfect room to talk about this, there is literally creativity written on the wall. We try and make these challenges open for a little bit of creativity. So if you have a team of students, let one of them talk about marketing. Let one of them come up with a brand name for your project. Let them design the backdrop, design a new sprite. Let them have that creativity, because it builds so much more engagement in it. As I've said, we keep things quite open and allow people to take it in a different direction. Sometimes that makes it harder for the teachers in the room, because students break things in unknowable ways. And we try and build in an artistic element to at least half the projects, make sure that everything has some avenue of creativity in there. So whether it's with turtle stitch, whether it's with the patterns that people create, whether it's with an LED screen. The one on the right there is from a game. Yeah, right, I've got teachers flipped syndrome. So it was from a game called Chuck a Duck, where if you shake it, the duck disappears from your screen and appears on someone else's. And then they shake it and it appears somewhere else. And a student went, that's cool, but the duck looks rubbish. I worked very hard on that duck. So they decided to make this instead and had a multicolored rainbow pattern instead. And I think that is so much more engaging and so much more inviting. So when we do that, genuinely it is the best activities I ever get involved with. When we have this buzz of the students really believing that they are building this future city, they are doing something that is relatable to them, something that is powerful and has an impact on society. We see them leave at the end of a week or the end of a day really inspired. And that's the value of these block-based coding things, that we really are able to deliver something unique and special to young people. Students within the teams have different roles. So some of them will focus on fixing one particular problem. Some of them will focus on another thing. And then we have integration hell when they try and bring it together. There you go, it's an experience of the real world. And it means that there is something for everybody on that team, okay? This is one where I take off the kind of the computer science, the programming hat a little bit and talk about marketing. We want to be able to show this stuff off and show how great these projects are. We are able to make our challenges topical by having these challenge cards. So Coventry was the city of culture when we ran one of these projects. So we were able to say to students, show Coventry off to the world. What's special about Coventry? Make it topical to something we're doing. So putting my talk straight after one, showing you the amazing things that microbits can do, perfect, very topical. It's more fun for us as the presenters because we see something different every time. I mentioned the beeps on the traffic lights. I've mentioned the things like people trying to interfere with radio signals and making sure that the microbits have some kind of error checking or pass key, that kind of thing. And I find that the students really get engaged and have more interest in it. If you'd like to know more about any of this, we do have our resources up on our website that you can see up there. Margaret and I are both on LinkedIn and Twitter, and you can ask us lots of questions. I think what I want to do with this session really is just encourage people to try out this challenge card approach. Think of some challenges that you could do. Maybe if you're in a room with some young people, how many of you have had that moment where they just completely shut down from a big wall of text? A big code or my code doesn't work, forget it, I'm not doing it. But when you have this kind of, here's a starting point, make a triangle, move it a bit, spin it. How many of you go away from that and think, I want to carry on doing that and come and find Phil at lunchtime and make him do more stitching? That kind of thing. That engagement really builds. So give it a go. What have you got to lose? Questions? So that's a couple of questions. How long do they have? It depends on the project. So we have different challenges for different length of projects. The one we ran last week was 5 days of work experience, and they had roughly 8 or 9 hours across that week to work on a group project in a team of 6. So we're talking about 40 to 50 people hours of work on an individual project. We have much, much smaller challenges that are based on pairs, maybe with 4 hours of time, which is what we're doing next week down at the Royal Institution. So that is more like maybe 8 people hours working on a project. The age ranges, this is something that for the longer projects, we would look at 15-year-old students. So year 10 in the UK, 14 to 15. For the younger side of things, we're maybe looking at 11 to 13, getting them that introduction and get them to build the kit. If we need to save time, we can build some of the peripherals in advance, put the robot vehicle together. If we've got more time, we can leave it all to them. So there's flexibility in the approach. And once you've got a bank of challenges, you just pick the best ones for that session. Good question, though. Questions? Okay. Thank you very much.